Okay, earlier today in our lecture, here's some of the notes. We had x squared y squared plus xy equals 2, and we had to find the derivative, and we did. And this was our derivative here. What I then did is I said, okay, for the same curve that I gave you originally here. And by the way, this is that curve. It looks like this star here, x squared y squared plus xy is 2. So there's that curve we were referring to earlier. So we got down and we said, let that first derivative equal -1 here. dy dx is -1. They want us to determine the points on the curve where the slope of the tangent line is now -1. So we plug that in. We did our algebra, and I said to you guys, this is the equation we get. And I wanted to know, what does this mean? So I asked you guys to think about that. Okay. So what I'm going to do now is I'm going to show you what this means for that particular curve. And I'm going to scroll all the way down from our notes. So I'm going to answer for you what that means, because I know there'll be some of you who will either visit me in office hours or actually take a look and ask for this question tomorrow, what it means. So I notice we have a common term here, 2x plus y, or 2xy plus 1 there is common. So I'm going to subtract or translate 2x plus y, or 2xy plus 1 minus x, 2xy plus 1 equals 0. I'm going to factor that term out. I'm going to solve this equation. And there again is that common term, 2xy plus 1. Now, what that means is, by the product rule, this times this. This means 2xy plus 1 is 0, and it means y minus x is 0. I can solve here on the right for x. That means y is x. Good, we're going to use that information. And I'm going to solve for xy here. So subtract 1, divide both sides by 2, and now xy is -1/2. So what I'm saying is, what this means when I solve this equation is I get this relationship. xy is -1/2, and y is x. And so we're looking at this, and we're going to try to make some sense of this. Remember the original curve. X squared, y squared, plus xy is 2. That's the original curve. And so what I'm going to say here now is this, right? So this is my two solutions for the derivative being equal to 1. What I'm going to say now is, if xy is in fact -1/2, then when I square xy, I'm squaring -1/2, which means x squared y squared is +1/4. And if I then say I'm taking x squared plus y squared plus xy, using my assumptions, meaning -1/2, +1/4, I get 1/4 minus 1/2, and that equals, multiplied by 2, -1/2. So I'm saying that this is what I get by this assumption. And that's not possible for this question, because we know that it's supposed to equal 2. This is the curve they gave us, and it's supposed to be, as a sum, equal to 2. Now you say, what does that mean then? That means this assumption's wrong. We cannot use it. It means we get to throw this portion out. It's not valid. So then you say, well, what does the other portion mean then? So, okay, now if y is x, they're saying y is the same value as x. So what that means is, if in fact y is x, then here's what this means. The original question, y is x, wherever there's a y, replace it with an x. And what that gives you now is x squared, xx equals 2. Algebraically, x to the fourth plus x squared is 2. I can subtract 2 from both sides and I get x to the fourth plus x squared minus 2 is 0. I'm going to get rid of some of this stuff. This was, by the way, question 51 in our book, in our homework. This is question 51. So anyway, get rid of this here. And this is what we're saying. If, in fact, y is the same as x, we get to solve this for x. Now, we can solve this. This is quadratic in form. I can say, let t be x squared. So that now gives me t squared plus t minus 2 is 0. Factoring here, I get t is plus 2, t minus 1. Okay, that means t plus 2 is 0. It means t minus 1 is 0. From the 0 product rule, it means t is negative 2, or it means t is positive 1. But we're saying t is x squared. So I can find the value of x. This means x squared is negative 2. It means x squared is positive 1, because that's what t is. This is quadratic in form. Now, I get to throw out x squared is negative 2, because if I have to solve for x, which I do, I get a complex solution. So this is calculus of a real variable. When I solve for x over here, since x squared is 1, I get x is plus or minus the square root of 1. I get x is plus or minus 1, ladies and gentlemen. So x is two values. X is positive 1, and x is negative 1. Those are the two values. All right. Okay, these are my x coordinates. They want the locations. So for the locations, go back to the original relation. Those are all points on this curve. So what I'll have to do, I'm going to copy this here. Here we go. Here's my original relation. If I plug in x as 1 now, okay, I can find the y values, meaning I get y squared, it's really 1 squared, plus 1 times y equals 2. Y squared plus y equals 2. Y squared plus y minus 2 is 0. And now I can factor and solve this quadratic. So this will be 2, and this will be 1. This is plus 2, and this is y minus 1. So get y plus 2 is 0 by the 0 product rule. Y minus 1 is 0, which means y is 1. Here, this is y is negative 2. So this is happening when x is 1. So you can say x is 1, y is negative 2, x is 1, y is positive 1. Now remember, this is all based on the assumption that y is x. So I get to throw this out. I get to throw 1, negative 2 out as a solution. And so 1, 1, this location is where my derivative will have a negative 1 slope at 1, 1. And if you go back and you look at our relation here, 1, 1, we'll have a tangent line there that will be -1. This is what they mean by that. It's a negative slope for a tangent line at that location. What you want to now do is look at the situation where x is -1. Because we did x is 1 now, we have to look at when x is -1. So when x is -1, plugging that back into our relation, -1 squared x squared plus -1 x will be 2. X squared minus x is positive 2. And I think these are the y values. I apologize. Y squared, y squared minus y. So this is y squared minus y minus 2 becomes 0. I can solve this by factoring as well, using the zero product rule. Get y minus 2 is 0, or y is 2. Y plus 1 is 0, or y is -1. And this happens when x is -1. So you can say -1, 2, -1, -2. Those are the x and y coordinates. But again, you throw this out because this is all based on the assumption that y is x. So here's my second location at -1, -1 here. And that's how we look at this answer. So there's two locations. 1, 1, -1, -1. Here is the answers to these questions here, right here. -1, -1, +1, +1. And if we go back to the browser here, we look at the shape. -1, -1 is down here. And what they're saying is, if I can get there, you'll have a slope at that location being -1. And so this is what we were looking at this morning, ladies and gentlemen. All right. I'm going to look at now a second video. Here we go. What we're going to look at now is right in here. Let's see if we can find the notes here. I'm going to go to the browser now. Yes. Or Lemisket. We're trying to find the location of horizontal tangents. Now, I'm going to give you guys a heads up. If I can touch this here, I guess I can't. All right. I see 4 locations of horizontal tangents on this relation here. Quadrant 1, 2, 3, and 4 has only one location. And so let's take a look at what we looked at earlier in the iPad.